let's move on to variables. Now, variables provide names for values in programming. It's a way for you to store a value. If you want to save a value for later or repeated use, you give the value a name. Storing the contents in a variable. Variables in programming work in a fundamentally similar way to variables in algebra. But in Python, they can take on various different type of data types, meaning they don't necessarily just need to be number. It can be strings and many other things as well. So the basic variable types that we will cover in these sections are integers, floating point numbers, booleans, and also strings. Integers is 1, 2, 3, 4, so there's no decimal. Floating points basically is 1 point. There could be lots of 0. It's basically a real number as such. Booleans is either true or false, or 1 or 0, and strings is, as you know, strings. An integer in programming is the same as in mathematics, a round number with no values after decimal points. We will use the built-in print function here to display the values of our variables as well as their types. Right, in this cell, I'm going to just run it so that you can see the actual output. The first one is that we store the value 50 into this variable named myInteger. The next line of code, we're going to print myInteger, comma, and also the type, the data type of the actual variable itself. So when you print it, it first of all print the value of the variable, which is myInteger, and also the type and it tells you here the type is actually an int, which is short for integer. So if we move on, variables, regardless of type, are assigned by using a single equal sign. Variables are case sensitive, so any change in variation in the capital of a variable name will reference or refer to a different variable entirely. So here we have 1, the value of 1 or integer 1, is stored in the variable called 1, O-N-E. So when you print the capital letter O-N-E, now remember Python is cap sensitive or case sensitive. So if I print this, what do you think will happen? Think for a second. Nothing. It will give you error because we didn't store any value into capital 0 and E. So let's just run this. Hopefully it runs as I expected it, and sure enough, yes, 1 is not defined. It gives you an error because we did not store the value into capital 0 and E, but we store it in 1. So just to prove the point, so if I print 1, you should actually get the value 1. Okay, good. So let's scroll down a little bit. A floating point number, or a float, is a fancy name for a real number. Again, as in mathematics. To define a float, we need to either include a decimal point or specify that the value is a float. And here are different ways to do it. The first one is we have a decimal point 1.0 and store it into this variable called myFloat. And then we print it, what's the value in the variable called myFloat, and also print the type as well. The second way of storing the value is we specify using a built-in function called float and bracket and put our value in the middle of it and store this again into myFloat. Now notice that this will override this previous value, but that's okay because we already printed out. Okay, so when we print it again, it will most likely, in fact, it will actually print this exact same thing. So let's just print it out, and yes, sure enough, it's exactly the same thing. So why are there two lines? This is the first line where we ask Python to print what is the value in the variable myFloat, as well as the type. The type here happens to be float because we specify 1.0. It's a bit different from before. It's an int, which is short for integer. Here we print again, the variable. What is the actual value of the variable? It gives us 1.0, sure enough, because we store float bracket 1, which specify or clearly or specifically that this is to be a float, and the type is a float as we have specified here. So a variable of type float will not round the number that you stored, while a variable of type integer will. This makes floats more suitable for mathematical calculations where you want more than just integer. Note that as we use the float function to force a number to be considered a float, we can use the int bracket function to force a number to be considered an int. So here, my int is equal to integer 3.14159, that's pi, just in case you don't know. Here we store the value int bracket 3.14159 into this integer, this variable name called my underscore int. And when you print it, and what you get is my int. It should really be 3 because the int function, bracket function, basically only take the integer value and drop the rest. Okay, and the type should be int. Let's have a look. And sure enough, it's a 3 and the type is an integer. So int function also truncates any digits that a number may have after the decimal point. So remember this, it truncates, okay, all the value that's in the decimal point. A string allows you to include text as a variable to operate on. They are defined using either single quotes or double quotes. But you do need to be consistent. Okay, here you have 2 single quotes, here you have 2 double quotes. Right. Okay, so just look at an example on my string. This is a variable name. This is a string with single quotes and print it. And my string, this is a string with double quotes, and they should really be exactly the same when I run it. Okay, here you go, with the exception of single and double. So both are allowed so that we can include apostrophes or quotation marks in strings if we so choose. Here, let's just Jabberwocky by Lewis Carroll. Here you have double quote inside with the single quote outside. So when you print it, it will include the double quote. Occasionally you want single quote, so you have a double quote on the outside. Okay, so when we print this, there we go, double quote, Jabberwocky by Lewis Carroll, and single quote, "'Twas brilliant." Oh, I don't know how to read this. I'm just going to leave it to you to read that one. Booleans or bools are binary variable types. A bool can only take on 1 or 2 values, these being true or false. There's much more to this idea of true values when it comes to programming, which we will cover later in the logical operations of this notebook. Here, my bool, my underscore bool, is equal to true. So when you print it, it will show you this is a boolean and the value should be true. And here you go. There are many more data types that you can assign as variable in Python, but these are the basic ones. We will cover a few more later as we move through this tutorial.